Alright, welcome back. This is actually my second attempt at recording this video for 5.1, multiplying and dividing polynomials by a constant. My first recording didn't work out very well, so here comes take two. Welcome back again, my wonderful students, and you guys are the best. So here we go, here we are. This is multiplying and dividing polynomials by a constant. This is 5.5. Here's the objectives that you were going to learn, and I'm going to try to teach you to be able to multiply polynomials by a constant. In this case, this constant really is just any integer. Also be able to divide polynomials by a constant or integer. I'm going to upload these notes in your Google Classroom as well, so you have access to it. But don't worry about this part here. This is a thinking classroom problem. Okay, so if and when this COVID situation ever does leave us, then we'll be able to do this as a thinking classroom, this kind of problem. But first, I think I'm going to divide this video into two parts. One part is multiplying polynomials by a constant, and the other one is going to be dividing polynomials by a constant. So here we go. This one is part one. Let's multiply. This first example you have is a monomial multiplied by a constant here. Okay? And just to recall for you, the meaning of multiplication really is just a repeated addition, is it not? So let's say you have, I don't know, 3 times 4. That really means you can interpret this way: 4 of 3s or 3 of 4. In this case, 3 of 4 would look like this. This would actually be equal to 4 plus 4 plus 4, which gives you 12. In this case, the only difference is they have this x variable attached to it. But really, that's what multiplication is, okay? But yeah, so what are they trying to show you here? Basically, it's when you're multiplying a monomial with a constant, you're really just multiplying the coefficient and the constants together, and then the x is just telling you what it is that you're multiplying. In this case, we're multiplying x's. Okay, you have 3x present, you're going to multiply it by 4, and you're going to end up with 12x. Okay, and they try to model this using tiles right here. Okay. Like, I know this looks very compact and neat and all, and I guess they try to make it into an area model where this part here is actually 3x and this part here is actually 4. So there's where your 3x times 4 comes in. Okay, but let's say you didn't have it. You were going to draw this for the first time. It really doesn't need to be this compact and neat, really. Again, this is like an area model, it's a rectangle model, but if you really, if you were going to draw tiles for me, I'm also okay if you drew 3x first. Okay, so I'm going to draw you 3x, and they don't necessarily have to be attached either. There's my 3x, but I am ordering 4 of them, so I'm going to have to draw this 3 more times, like this. That's 2. There's 3, and finally there's 4. Okay, and I did my best to try to make them all the same size, but you get the idea. This is well, there's 4 layers of them, so how many x tiles you end up with? Count them: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 x tiles. Okay. So that's multiplying a monomial with a positive constant, like a positive 4. But you might ask, and I will show you what happens if you multiply a monomial by, a constant with a negative monomial. Okay, and again, this is a repeated 4 of negative 3x. There you go, negative 3x plus negative 3x plus negative 3x, which will equal to negative 12x. Okay. But as far as drawing it, I'm going to redraw this for you again. This is how you can draw this if you want to, okay? Draw yourself the 3x again, okay? But not 3x, we need negative 3x, so I have to shade these guys in. By the way, in the textbook that I also shared with you, this is actually colored red, and this lightly shaded one here is actually yellow, so sorry about that. That's my phone notification. I'm not going to answer it right now because we're busy learning. So I have my negative 3x. Oh, that's a school bell. Sorry. I have a negative 3x, but again, I need 4 of them. So I'm going to draw this again 3 more times. Like so. Get to shade it in. And then I'm going to draw it, need to draw it 2 more times. Now I'm going to turn off all my notification sounds. There we go. 1 7. And so I have 2 right now. I need 2 more. Again, trying to draw it. And again, I don't mind if you draw it like this. Okay, it doesn't necessarily have to be as compact as that one, because you'll see later on all the other examples that we're going to have when we get to binomials or trinomials. You can't draw it as compact as this. Okay, maybe there is, but I'll figure it out. So there we go. So the only difference here is, you know, when you're multiplying 4 times negative 3x, you're drawing shaded in tiles. And your final answer would be a negative, because 4 times negative 3 is negative 12. Okay? Same thing if the constant is a negative. What if you have a negative 4 times a positive 3x? Well, your answer is still going to be negative 12x, and your tiles are still going to be shaded in. The same thing. Okay? Let's try another one here. This is what's happening. What is happening in this example over here? Well, I'm going to again redraw this for you and tell you what's going on. This one is now 3 times negative 2m plus 4. Okay, so with tiles, what they want you to do is draw basically 3 rows. They need 3 rows of negative 2m's plus 4. So what I'm going to do, actually, I'll show you how this is done over here. And again, it doesn't have to be as compact as this. I'm going to draw my negative 2m. And I'll draw my 4 positive little ones. Okay. And how many did they order? They ordered 3. They want you to draw 3 of these. I have 1 already, so I'm going to draw it 2 more times. The same set of tiles. Don't forget to shade in what you need to shade in. Okay. And there we go. Okay, and it doesn't necessarily have to be compacted together like this one. So now if we count these tiles, what do we end up with? Well, really this is my negative 2m plus 4, and over here they're asking you to do 3 of them. So counting the tiles, what is this equal to? 1, 2, 3, 4, 5, 6 negative m. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 positive little ones. And isn't that the polynomial that we want to calculate? And now here, with the polynomials, I'll show you exactly, again, I'll start this from the beginning and show you how to do this, okay? So I'm going to write the same question again, 3 times negative 2m plus 4. So what they're really doing here is using distributive property. It means they're distributing this 3 to each of these items inside this bracket. So when you multiply it out, you're going to have 2 multiplications here. You're going to have 3 times negative 2m, and you're going to have 3 times positive 4. So what does this multiplication look like? I tried to show it to you there, but here it is again. You can do it like this as well. Notice I have brackets around there. It really doesn't matter. So 3 times negative 2m here, and plus 3 times positive 4 there. Okay? So there's your 2 multiplications. Well, what is 3 times negative 2 here? That's negative 6m. And what is 3 times 4 here? That's equal to positive 12. Okay? And that's multiplying constant by binomials. Our next example is here. Okay? This time we have a trinomial multiplied by a constant. Okay, so what is it trying to show you this? Okay, first of all, in the notes that you're going to get in this copy of the notes, what they did first is they drew the tiles for this, items inside the bracket. They have they have an n squared, negative n squared, and they have 2n, and they have a minus 1. And then they want 2 of them, so they drew 2 of those. And then because that negative 2, that 2 is actually, it's a negative, they reversed or flipped to its opposite because of the negative 2. So they changed it to its opposite. You see this? Okay, so in the end, it's negative 2 times negative n squared plus 2n minus 1 is positive 2n squared minus 4n plus 2. But I actually want to save you some time here, okay? If you want to, I'm going to rewrite the same question here. If you want to, if you want to, you can actually, you can already see that a negative times a negative here is going to be a positive, okay? Then that calls for you to draw a positive square tile, right? So you can actually skip through this drawing and go right to here. If you can see it already, that a negative times a negative here is going to change it to a positive, and a negative times a positive here is going to change it to a negative, like so, and a negative times a negative here would give you a positive. Okay, you can actually skip that if you want to. Okay, that first drawing, I mean, but then now you have to draw this twice because they want 2 of them, right? Oh, pardon me. This is supposed to be just a positive 1 because the original tiles would be a negative, opposite of negative 1. So this is the resulting tile after we ordered 2 of these in their opposites, because this is what that negative does. It turns it to its opposite. Okay? And if you remember the multiplying integer rules, this is important to remember. A negative times a negative equals a positive. A negative times a positive will give you a negative. A positive times a negative equals a negative. And a positive times a positive give you a positive. Basically, if the signs are different, it's going to end up being a negative, okay? Let's try this here again. This time I'm going to redo this question for you, this example for you, and I'm going to do it for you in motion. Okay? Negative 2 times negative n squared plus 2n minus 1. Again, using distributive property, what they want you to do is take this negative 2 and multiply it by each item inside this bracket. So you can have 3 multiplication. Okay? Negative 2 times negative n squared. Negative 2 times positive 2n. And negative 2 times negative 1. Watch how this plays out. Take my negative 2. Oops. Sorry. My negative 2, and I'm going to multiply that with this negative n squared. I'm also going to take this negative 2 and I'm going to multiply it by this positive 2n. I'm going to do this. I'm going to put an addition here for now, because I'm negative 2 multiplied by positive 2n, like so, plus one more multiplication, which is negative 2 times negative 1. Okay? And now I do the multiplication here. Remember that even if I don't put a 1 in here, or a negative 1, that means there's a negative 1 in there. Okay, so this is actually negative 2 times negative 1, which gives me a positive 2 n squared. This is a negative 2 times a positive 4, which means gives me a negative 4. So that's what I have to write down, a negative 4n. And over here is a negative 2 times negative 2 times a negative 1, which gives me positive 2. And that's exactly what they showed you up here in this example. I just wanted to redo it for you to point it out, okay? Okay, so I hope that helps with the tiles and the polynomials, multiplying. Guess that's it for those examples of multiplying polynomials for now with a constant. Hope this video helps. And again, if you have any questions, you can always message me, post a message and email me, and I will try to get back to you as quickly as I can. But otherwise, bring your questions to our Google Meets. I believe our next one will be Wednesday. Okay? Yeah, I believe it'll be, nope, it'll be Thursday, sorry. Okay, so bye-bye for now.